Hello everyone, my name is Amruth and today I will be walking you through the incredible concept shaping our future, digital twin. Just imagine a virtual version of something physical. It might be a machine, a person, or even an entire city that mirrors in real time, evolves, learns, and helps us to understand it better. That's a digital twin. It's not just a 3D model, it's a dynamic entity powered by live sensor data, advanced analytics, and AI. And today we'll be exploring how they work, what makes them work, how industries are using them, and why they are being called the future intelligent systems. Let's dive in. Okay, now for any digital twin to perform seamlessly and function effectively, we need five core sensors which can be used inside the digital twin. The first one being a physical entity or the sensor and the digital model, then comes the connectivity layer and comes the AI, ML and analytics tools, and then the dashboard or a AR VR system by which we can visualize what's happening inside a digital twin. First comes the physical entity. Any physical entity like a human or a machine or even a building for that fact can be connected with sensors that continuously collect the real-time data. This real-time data will be sent into a digital model which replicates and mirrors the real-world behaviors. Then comes the connectivity layer, which is often referred to as the digital thread, ensures that this exchange is continuous and instant. Then comes the AIML or the analytics tools, which interprets the patterns, makes predictions, and optimizes the performance of a digital twin. Now, when all this is happening, we need something to visualize all these things. Though, so the visualization happens through the dashboard or the AI, AR or VR. When we have the dashboard or the AR VR setup ready, this does not allow us to just monitor the system, but it actually helps us to simulate and forecast the real world entities. Now, I'm sure we all learned about the core like components of a digital twin. Now, let's dive deep into the historical roots and the market growth of a digital twin. Coming to the history, the concept of digital twin isn't entirely new. It dates back to 1960s when NASA used to simulate for Apollo missions. They used to mirror the spacecraft systems on Earth in real time. In 1997, Dr. Michael Graves formally coined the term digital twin, and it quickly gained traction in aerospace and manufacturing industries. But now we As we now know about the brief history and the components and how a digital twin actually works, let's dive deep into the use cases of a digital twin. Aerospace and automotive sectors. The aerospace and automotive sectors have been among the earliest adapters of digital twins. NASA still uses digital twin to simulate the spacecraft, ensuring the mission's safety and reliability. Companies like Boeing are using live data from aircraft systems to improve the design and detect the issues before they become critical. I am sure you have heard about the BMW automotive company. Yes, in the automotive world, BMW is using Nvidia's Omniverse to build digital version of their factories before they are even built physically, optimizing the layout, worker safety, and resource planning. The outcome: smarter designs, reduced downtime, and safer systems. Now, let's dive into healthcare. One of the most promising frontiers of digital twin is healthcare. The Living Heart project by Dassault Systems simulates the heart's procedures, making surgery safer and more effective. The Cleveland Clinic developed patient-specific heart twins, reducing the surgical risk by 25%. Imagine having your heart virtually before you even get into a surgery. Imagine tailoring treatments based on how your virtual heart responds. That's personalized, medicine powered by digital twin. It's not just about the efficiency, it's about the better outcomes, fewer invasive tests, and potentially saving lives. Now, let's see how smart cities and environment is replicated by this digital twin. The digital twins are also transforming how cities are planned and protected. Virtual Singapore is live nation scale twin of over 5.7 million people. It manages traffic, optimizes energy, and even helps plan disaster responses. Cities like Houston and Amsterdam use digital twin to simulate and mitigate flood and heat waves. The Destination Earth project by EU is building a climate twin for our planet to simulate and prepare for global scale environment events. The potential to create safer, more resilient urban environment is truly revolutionary. Imagine a virtual Singapore. It means a whole nation is virtually replicated. One of the other use cases of digital twin and the interesting use case is energy and industry. Industries are seeing major benefits from digital twins, especially in energy and heavy manufacturing industries. Take GE's wind farms. Digital twins help adjust turbine blades angles in real time, improving the energy output by up to 20%. Sorry. Oil giants like Shell monitor offshore assets to detect issues early and reduce downtime. In mining, Rio Tinto uses twins to monitor equipment's health and reduces the environment damage. Across these industries, twin boosts operational safety, efficiency, and sustainability, delivering both economic and ecological benefits. And let's come to supply chain and retail agriculture. These are the demanding use cases of digital twin. Digital twin aren't just for tech giants or governments. Even retailers and farmers are leveraging them. Walmart uses twins to simulate customer flows and optimize the product placements. DHL builds virtual logistics systems to simulate the risk deliveries. In agriculture, John Deere simulates the crop health and machinery to maximize yields. This cross-sector adaptation proves that digital twins can enhance productivity, sustainability, and customer satisfaction no matter the domain. Now let's come into the digital twin maturity and processes. Like humans, digital twin also matures stage by stage. The five stages of this process includes descriptive stage, monitoring stage, predictive stage, prescriptive stage, and the autonomous stage. At the descriptive stage, they simply visualize and represent the systems. And as they grow, they monitor the real-time data, which is then fed into the predictive analysis for the forecast of the future events. At the prescriptive level, it goes one step further, suggesting the actions to be taken on the predictions. Finally, at the autonomous stage, the system can make its own decision and act on its own. This is powered by continuous CIP cycle. The CIP stands for create, inject, process, analyze, and optimize cycle. With each iteration of this cycle, the twin becomes more smarter and more accurate, revolutionizing how systems learn and evolve. At this point, I'm sure you might have got a brief idea of how digital twin actually works in real life and what are its use cases. And I'm sure the use cases have made you more familiar for the concept of digital twin. Now let's dive into the benefits, challenges, and the future outlook of these digital twins. Let's first see the benefits of the digital twin. The digital twin offers incredible benefits. The predictive maintenance to cut on downtimes, the design acceleration to get products to market faster, the resource efficiency to reduce wastage, and smart planning for green cities and personalized healthcare. But with all these benefits, digital twins also come with a cost. So the challenges always remain, particularly around the data privacy, collaboration, and cybersecurity. Think about the projects like Toronto and Portland, paused due to privacy concerns. Yet, if we can address these issues, digital twins will be the core of every intelligent systems we build globally. and it's time to conclude the video. And digital twins are not just a technology, they are a philosophy. They unify the physical and digital worlds to create the smarter data driven ecosystems. From aerospace to agriculture, they are helping us to build more resilient, sustainable, and intelligent systems. As technology evolves, it reaches everywhere, in home, hospitals, factories, and entire cities. However, with great power comes great responsibilities. Ethical implementation, security, and trust will define the next chapter of digital twin innovation. Hope you all liked the video and it was knowledgeable. Please do like and share. This is Amruth signing off.